Chapter 10, Air and Water. Get into. Complete the given puzzle to find things related to air and water. Number 1, gentle wind. Number 2, we need this to breathe. Number 3, very strong wind. Number 4, frozen water that we use to chill our juice. Number 5, we need this to drink. Number 6, water is present in this form in the air. Number 7, water falls down from the clouds as this. Air and water are essential for all living beings to survive. All living beings need air for breathing and water for drinking. Let us know more about these two essentials. Air, atmosphere. The thick blanket of air that surrounds our Earth is called the atmosphere. The gravity of the Earth holds the atmosphere in place. It extends from the Earth's surface to about 800 kilometers above the Earth. The density of the air varies with height. It is thick near the ground and gets thinner as we go up until it fades in outer space. Importance of atmosphere. The atmosphere contains oxygen which we breathe. It contains carbon dioxide that is used by plants to prepare their food. A large part of the heat coming from the sun and reaching the earth is stopped by the atmosphere. Ozone, present in the atmosphere, prevents harmful ultraviolet rays of the sun from reaching the earth. These rays can cause eye problems and even skin cancer. The atmosphere protects us from the meteors that can cause great damage if they hit the Earth's surface. Layers of atmosphere. The atmosphere is divided into 5 layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Troposphere. It is the layer of the atmosphere closest to the Earth's surface where organisms live. It contains water and gases, mostly oxygen and nitrogen. It is about 15 kilometers thick. Winds blow, clouds build up, and weather changes take place here. Stratosphere. It is above the troposphere and is about 35 kilometers thick. It is a clear, cloudless layer where planes fly. The upper part of the stratosphere is the ozone layer. The ozone acts as a huge shield, protecting us from the harmful ultraviolet rays of the sun. Mesosphere. Meteorites and small rocks moving about in space burn out in this layer. Therefore, this layer prevents meteorites from reaching the Earth's surface. Thermosphere. This layer is also known as the upper atmosphere. Space shuttles orbit in the thermosphere. Exosphere. It is the outermost layer of the atmosphere. It is the thinnest layer with very little air. Beyond the exosphere lies space. Composition of air. Air contains gases, water vapor, and dust particles. Gases. Air is a mixture of many gases. Nitrogen forms about 78% of the complete atmosphere. It being inactive keeps the process of burning under control. Plants get nitrogen from the soil, and animals get it from plants. About 21% of the atmosphere comprises of oxygen. It is essential for the survival of all living beings. It also helps in burning. Other gases, such as carbon dioxide, hydrogen, argon, neon, etc., form the remaining 1% of the atmosphere. Carbon dioxide is used by green plants for photosynthesis. Composition of air. Nitrogen 78.08%, oxygen 20.95%, argon 0.93%, other gases 0.04%. Infomine. Neon is used in colorful glow signs. Argon is used in electric bulbs and helium gas and is filled in balloons. Humidity. The amount of water vapor present in the air is called humidity. During the rainy season, humidity in the air increases. Dust and smoke. Air also contains particles of dust and smoke. The more the dust and smoke, the more polluted the air becomes. Properties of air. Let us learn different properties of air through some fun activities. Air has weight. Pull up your sleeves. To show air has weight. Materials needed: an inflated balloon and a good weighing balance. Procedure: weigh the balloon accurately and make a note of it. Now squeeze out all the air possible out of the balloon. Again, weigh the balloon and make a note. Now compare the two weights. You will find that the inflated balloon is heavier than when it is squeezed out of air. It shows that air has weight. Air takes up space. Pull up your sleeves. To show air takes up space. Materials needed: a bottle, a small funnel, a straw, modeling clay, and a cup of water. Procedure: seal the funnel tightly into the neck of the bottle with modeling clay. Pour the water into the funnel quickly. The water stays in the funnel because the air in the bottle cannot get out. Remove the clay from the neck of the bottle slowly. You will see water going down into the bottle because the air gets an escape from the space left between the mouth of the bottle and funnel. It shows that air occupies space. Air exerts pressure. Pull up your sleeves. To show air exerts pressure. Materials needed: a glass tumbler, a piece of thin and flat cardboard, and water. Procedure: fill the glass till the top with water. Place the cardboard over the glass. Carefully turn the glass upside down, holding the cardboard tightly to the glass. Take your hand away from the cardboard. The cardboard stays in place against the glass. It shows that air on the outside exerts pressure on the objects around it. Uses of air pressure. Air pressure helps us to drink through a straw. When we suck at the straw, air is removed from the straw. Air pressure on the liquid pushes it to rise in the straw, which has lower pressure. A doctor's syringe also works on the above principle. When the plunger of the syringe is pushed inwards, all the air is removed. The needle is put in the medicine and the plunger is pulled out. Medicine goes into the syringe as there is no air, hence a lower pressure. Air pressure. Pressure less than air pressure. Liquid being pushed up in the straw. Air pressure. Plunger. Low pressure. An ink dropper also works on the principle of air flowing from higher to lower pressure. Find an answer. If an astronaut would play drums in space, on the moon, would he or she be able to hear it? Why or why not? Water. Like air, water is also essential for life. It is used for drinking, cooking food, bathing, washing clothes, etc. About 70% of the Earth's surface is covered with water. Water has many properties, such as: pure water is colorless, tasteless, and odorless. As water dissolves many things, it is also called a universal solvent. Water exists naturally in all three states: solid, ice; liquid, water; and gas, vapor. As it can absorb heat, it is used as a coolant in vehicles and factories. Rainwater is considered pure, but as it reaches the Earth's surface, it dissolves various impurities from the air and from the ground. Impurities in water. The substances that make water unsuitable for use are called impurities. Sand, dirt, mud, and germs are some of the impurities. The impurities found in water are of two types: soluble impurities, insoluble impurities. Salt, soluble impurities. The impurities like salts, chemicals, minerals, etc., are dissolved in water. These are called soluble impurities. Muddy water, mud, insoluble impurities. The impurities like mud, stones, sand, etc., do not dissolve in water. These are called insoluble impurities. Removal of impurities. Removing insoluble impurities. Insoluble impurities can be separated from water by the methods of filtration and sedimentation. Filtration. The insoluble impurities in water are removed by making the solution pass through a funnel with filter paper placed in it. A flask below the funnel collects the clean water, while the insoluble impurities are blocked by the filter paper. Beaker containing mixture, filter paper, residue, funnel, conical flask, filtrate, filtration. Sedimentation. It works on the principle that heavy objects settle at the base of the solution. The solution of water and the insoluble impurities are made to stand for a while. The impurities then settle down at the bottom of the container and are called sediments. This process is called sedimentation. The clean water is poured out in a separate container. This is called decantation. Decantation. Sediment. Glass rod to help in decantation. Clear water. Removing soluble impurities. We cannot remove soluble impurities from water by sedimentation and filtration. Evaporation and distillation are two methods by which these impurities can be removed. Evaporation. In evaporation, the solution containing soluble impurities like salt, sugar, etc., is heated till the water evaporates and changes into steam, leaving behind salt, sugar, or any other soluble impurity. During this process, water is lost through evaporation. Evaporation. Heat. Solution becomes more concentrated. Evaporating basin. Steam. Distillation. The process of distillation is performed under these steps. Number 1. The impure water is taken in a flask and heated. Number 2. On heating, water is converted into steam and the impurities are left behind. When the steam is cooled after passing through the condenser, it turns into liquid water. Number 3. The pure water called distillate is collected in a conical flask. Distillation. Bunsen burner, wire gauze, distillation flask, condenser, conical flask, distillate. Infomine. Distilled water is used in vehicle batteries, medicines, and for science experiments. Purification of drinking water. Drinking water needs to be purified. There are different ways to purify drinking water. Let us read about them. Boiling. Boiling is one of the simplest ways to purify drinking water. Boiling water kills germs present in water and makes it safe for drinking. Boiled water should be stored in clean and covered pots. Boiling. Chlorination. Chlorine is a chemical element added to water to kill germs. The process of purifying water by adding chlorine is called chlorination. Up for review. Correct the false statements by changing the underlined words. Number 1. All non living things need air to breathe. Number 2. The atmosphere contains nitrogen, which we breathe in. Number 3. Exosphere is the layer of the atmosphere closest to the Earth. Number 4. The thick blanket of the air that surrounds our Earth is called the mesosphere. Take a look. Atmosphere, air, gases, humidity, dust, and smoke. Layers, troposphere, stratosphere, mesosphere, thermosphere, exosphere. Removal of impurities from water. Soluble, evaporation, distillation. Insoluble, filtration, Sedimentation.